All right, hey there, everyone. This is part two now of the video, so we're going to continue where we left off. So we left off here on number nine. On number nine, it said we knew we had a factor, which means we had an x-intercept, and then they gave us a second x-intercept, or second zero right here at 1. So I did synthetic division to get rid of the negative 1, to divide out the positive 1, and here's what I'm left with. And now my goal is to set this piece equal to 0, so that I'm able to figure out my other x-intercepts. I know from the original problem I should expect 4. I've got one here, one here. That means this will give me the other 2. So typically our first step is we want to look to factor, if possible. Unfortunately, there's nothing that multiplies to a positive 3, but adds up to 2. So factoring's out the window. I'm going to go ahead and use completing the square. If you're more of a quadratic formula person, that's legal too. So if I do completing the square, my first step is going to be to kick that 3 to the other side. All right, once I have that done, let's go ahead and set this up in factored form. We want to write this as x plus or x minus something squared. And to do that, I take half of my b value, which would be a 1, and I square it to fill in these blanks here. On the right side of the equal sign, negative 3 plus 1 would give me a negative 2. So now I have x plus 1 squared equals negative 2. Let me just go ahead and throw that work over here. I'm going to have to take the square root of this negative 2. Anytime I take the square root, I need to invoke a plus or minus symbol. And I don't like negatives underneath a radical, so I use the letter I to indicate that we have imaginary numbers, or numbers that would not show up directly as x-intercepts. And then to move that 1 to the other side, it would become a negative 1. So here are 2 answers. I've got 2 solutions there. They told me this 1, and then I was able to infer the negative 1 simply because they gave me a factor. If they give me a factor, that's just as good as giving me an x-intercept. All right, on to the backside. Let me adjust the camera here just a scotch. All right. Next up, we've got some factor action. So each one of these is going to employ a different style of factor patterns. So typically we have grouping that we covered in this unit. We have quadratic form, not quadratic formula, quadratic form. And then we had sum and difference. I don't know why I didn't capitalize the D in difference, whatever, of cubes. So those were the new factor patterns that we dealt with. All right, so let's take a look here. Number 10, there are 1, 2, 3, 4 terms. That's a big indication that I'm going to want to use grouping. So how this works is I'm going to look first at the first 2 terms and then at the second 2 terms. Within these first 2, I'm going to look for a GCF. Between x cubed and x squared, I've got a GCF of x squared, and that would leave me with an x plus 1 if I factored that out. Over here, I'll do the same thing. I've got a positive x and a positive 1. Well, I really can't take anything out. If you can't take anything out, well, just take out a 1. If I take out a 1, nothing changes. And I put a plus here as a reminder to myself that I took out a positive 1, so the signs don't need to change at all. I know I'm doing this correctly because my parentheses pieces match here. So I'll have x plus 1 times x squared plus 1. So now I need to solve each one of these because this whole thing is set to 0. I have 2 factors. Factors lead to solutions. This one's not going to be too challenging. It's just negative 1. This one might require a little extra work. I've got x squared plus 1 equals 0, so I'll move that 1 to the other side. Square root each side. So I'll get x equals plus or minus, positive or negative. Let's see, the square root of negative 1, well, that's just I. Plus or minus I, positive or negative I. All right, on 11. This is going to be a quadratic form. If we have something that's written as x to the 4th, x squared, constant value, that behaves the same way as if it was x squared x, then a constant value. So what I'm going to do is I'm going to bring that 27 over. So negative x to the 4th plus 12x squared minus 27. The reason I'm doing that is I like these to be equal to 0. What I'm not too thrilled about, though, is the fact that there's a negative sign attached to here. Well, no worries. To do that, I'm just going to divide everything by -1. And if I do the same thing to the other side, 0 divided by anything is still 0, so it doesn't matter. So x to the 4th plus 12x squared, oops, minus, look at me making mistakes, plus 27 now equals 0. So again, all of these signs changed. So that was positive to negative, negative to positive. All right, so now we factor. If this was an x squared minus 12x plus 27, it wouldn't be too terrible. You just think of numbers that multiply to 27 and add up to -12. Well, here it's the exact same thing. And those two numbers are going to be -3 and a -9. The only difference, instead of having a plain old x, we're now going to have an x squared. So it's still the same factoring process that we all know and love. There's just one extra step to it. Now, if I still see an x squared, I'm going to still try to factor that down. Here I'm noticing difference of squares. So difference of squares gives us conjugate pairs. So this is now what we're going to factor down into. And then I can get my 1, 2, 3, and 4 solutions. So x will equal 3, x will equal -3, and then x will equal, if I solve this out, it'll be positive negative square root 3. That's a whole lot of 3's. All right, number 12. Let's see. First and foremost, I like these things equal to 0, so let's go ahead and scooch that 8 over. It becomes positive when we do that. And this is looking like a sum of cubes pattern. So if it's a sum of cubes, I need to establish what is my a and what is my b values. Well, a is going to be what quantity cubed would give me 64x to the third, and that would be 4x. 4 to the third power is 64, x to the third power is x cubed. B is what number to the third power would give me 8? Well, that'd be 2. 2 would be that number. Now, I should also mention, if you wanted to, let me see if I have a different color pen to work in. See, a pencil would be good enough. If you wanted to, right, if these numbers are too big and we're not dealing with a calculator, it's totally fine to pull out a GCF first of 8, and then we'd be left with 8x to the third plus 1, and we could do our factoring that way. Actually, you know what? I'm feeling lazy. I'm going to go ahead and use this. So, boom, plagiarizing myself. So we have 8x to the third plus 1 set equal to 0. So I'm going to use GCFs to my advantage. If I divide out the 8 to the other side, 0 divided by anything is still 0. So now my a values, instead of dealing with 4x and 2, is going to be 2x and 1. Because 2 to the third power is 8, 1 to the third power is 1. Awesome. All right, so now with the factor pattern, we follow the SOAP process. So same, opposite, always positive for the signs. This first parenthesis chunk is always a plus b, so 2x plus 1. The second chunk here is going to be a squared, so it'd be 4x squared. And in the middle is a times b, so 2x times 1 is 2x. And then b squared, so that's 1 squared. Starting to wish I used a separate sheet of paper for this one. Dang it. All right, so right here we're going to have x equals -1/2 as one of my solutions. And over here, this is probably not going to factor out nicely, which means we're forced to use quadratic formula. So the opposite of b, plus or minus the square root of b squared would be 4 minus 4 times a times c. That'd be 4 times 4 times 1. So 4 minus 16 is -12. There'll be 12 with an I out here, all over 2a, so all over 8. There we go. So I've got 1, 2, and 3 answers, and I should have expected 3, so we're good. Cool. On to 13. Here we've got a graph, and we have to answer questions based on this function. I know that this function at the very least is cubic. It might be to the 5th power, might be to the 7th, but it's at the very least cubic. The reason I know that is one side's going down, one side's going up. So this is an odd function. The leading coefficient would be positive because the right side is going upward. As x becomes more positive, so does y. What is the relative maximum? So that would be this point here. The relative maximum is going to occur at the points -5, 4. You might have to word this as it reaches a relative maximum of 4 when x is -5, just as a heads up. The relative minimum is that point right there, -3, 0. Intervals on which f of x is increasing. So it's going uphill all the way until this maximum. So from negative forever, aka negative infinity, all the way up to -5. And then also from 3 until forever. So 3 to infinity. When is it decreasing? Well, it's only decreasing on this little stretch right here. So between the x values of -5, oops, forgot negatives on there, and -3. Write the polynomial now in factored form. Well, I've got an x-intercept there, an x-intercept there. So right off the bat, I know we're going to have an x plus 6 and an x plus 3. I already declared that it was a positive function, so no need for a negative out here. But this was a bounce point. So if it's a bounce point, that means it has to have an even multiplicity, so I'm going to give it a squared. It's not wrong if I put to the 4th or to the 6th or to the 8th power, but squared is the most basic one. So now just looking at this, I'd have 1x, 2, and 3 more x's. So if I were to distribute this out, and I'm not going to, but if I did, it would be x to the 3rd, blah, 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 and that fits that graph. Perfect. All right, number 14, last und final one. First thing I'm going to do is take a look at positive versus negative. I've got a negative out here, so I know the right side is going to be pointing down. Now I'm going to count up the x's to see if we're dealing with an even or an odd. See, this counts as 2, right, because we have a squared. So there's 2 here, then 3, then 4. So this would be x to the 4th with that -3 out front. So -3x to the 4th, blah, 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 which means that that's going to be my basic shape. So as x is going to negative infinity, aka the left side, my f of x is going to negative infinity as well because it's going down. Same thing for the right side as x goes to positive infinity. What are the zeros of the function? Well, I've got zeros at 1, at -1, and at 3. Remember, if you have a factor, you have an x-intercept. Those go hand in hand. What is the y-intercept? Well, the y-intercept is always just f of 0, right? So if we plug in 0 for x, what do we get? Well, this would be -3 times -1 squared times 0 plus 1 is 1 times -3. So -3 times -1 squared times 1 times -3. -1 squared is just 1 times 1. I can kind of ignore those because they're not going to do anything. -3 times -3 is going to be positive 9. Sketch the graph. Okay. Zeros of the function at 1 and -1, and then at 3. But I have to be careful because the x-intercept at 1, that was a bounce point. So I need to make sure that I make that known. And then our y-intercept was 9. 1, 2, 3, 4, 5. So, okay, our y-intercept is somewhere up there. It's not going to fit on the graph. That's okay. Maybe we'll scale it by 2s. 2, 4, 6, 8. Right there. Sure. All right, so I need to take this general shape and fit it to this graph. I know the left side is going to be going downward. I need to go through this x-intercept. I'll approach my y-intercept because I kind of made up where that was, to be honest. And now I'll turn around at some point, and I have to hit this x-intercept, but this is my bounce point, so I'm going to bounce off of it. Now at some point I have to turn back around and approach this next x-intercept. And this one I'm going to cross over and go through it. So that is a very, very rough sketch of what this thing might look like. All right, that's it. That's all, folks. You know the deal. If you have any questions, do not hesitate to reach out. Send me an email and we'll get through it.